All right, today we're starting off Chapter 9, which is the beginning of the polynomial unit. We're starting it today. You'll practice more in class, and today we're working on learning target. Let's see if I can get a pen to work. Learning target 34. We're working on classifying and naming polynomials, and then in class you'll be working on adding and subtracting polynomials. There's a lot of vocabulary coming at you today, and some of the things you'll be learning are about our monomials, binomials, trinomials, which all can be classified as polynomials. You'll be learning about standard form of a polynomial and degrees of monomials and polynomials, and then this is what will be in class the next day is adding polynomials and subtracting polynomials. First thing you need to know is a monomial is either an expression that's a number, a variable, or a product of a number and one or more variables. For instance, a number could be 5, it could be -3, it could be 100. Those are all numbers. A variable, some examples could be x, it could be z, it could be m, anything. Or it could be a product of a number and one or more variables. -3x, x, y, or even 2xy. That's what the product of a number and one or more variables would be. Here are some examples. It's -5 times x squared y. That's a monomial. K over 3, which is the same thing as 1/3 of k. That is a number multiplied by a variable, and also 32d over 11. Remember that mono means one, and what it's referring to is one term, and we've used that word term a lot. So my question is 6 over x a monomial? At first thought, you guys might look at that and say, yeah, it's a monomial, it only has one term. But in reality, if we take our knowledge of the last unit and we write this as 6x to the negative first power, it is not a monomial, so it is a no. And it's because for polynomials you cannot have fractional or negative exponents, so no fractions or exponents. No fractions or no fractions or negative exponents. Sorry about that. No fractions, no negative exponents. No fractional exponents, no negative exponents. So what we're going to look at first is the degree of the monomial, and this will help us in a little bit when we look at the degree of polynomials. The first one we have is 5x, and the degree of this, because on the x we just know that there's an exponent of 1, so this is a degree of 1. On the next problem, 3y squared, we are looking at the degree of the monomial, and it is an exponent of 2, so it's degree 2. What happens is in this problem, where you have 4x squared y squared, you add up the exponents on the x and on the y, so 2 plus 2, this would be degree 4, because we're adding the 2 and the 2. And here, some people, if I said, hey, figure out the degree, some people might say 7 first off, but in reality it's the 3 plus the 4, and don't forget there's a 1 there. So 3 plus 4 is 7, plus 1 more is 8, and that's a degree 8 for that monomial. Let's look here and practice what the degree of each monomial is. So we're going to try to determine that. So if you want to pause the video, try it on your own first and then check the answers. You can go ahead and do that now. Here are the degrees. The degree of this is 1 because the exponent is 1. B, this is hard. Wonder if anybody caught that. It's x to the 0th power, so the degree is 0. Here, 4 plus 2 is 6, plus 7 is 13. That's the degree here. And also here, it's showing the 0, so that's degree 0. On here, we can look at the degree a little bit more, and you can fill in your table. If you want to pause it again, go right ahead. This is x to the 0. This is a degree 0. This is a degree 7, which comes from the 5 plus 2. and the degree of this monomial is 4, don't forget you get the 1 plus 3 as your exponents, and it equals 4. So now we're going to look at what a polynomial is. A polynomial is a monomial, or the sum or difference of two or more polynomials. If we look here at 8x cubed z, 8x cubed z, we can see it is a monomial. Here we see a monomial being added with a monomial, and that makes this a binomial. The same way a bicycle has two wheels, a binomial has two terms. And remember earlier in the year we talked about terms being separated with an addition or subtraction symbol. Here we can see in this example, we have 4 terms, and that is a polynomial. It has 4 terms there. And what if we had something like 2x to the 5th minus x squared plus x, let's erase that, plus x, we would see that this has 1, 2, 3 terms made up of 3 monomials being added together, so this would actually be a trinomial. Tricycles have 3 wheels, trinomials have 3 terms, binomials have 2 terms, like bicycles have 2 wheels. Analyze different functions. So what we want to see here is that the degree of the monomial is the terms in decreasing order. So the degrees of the monomials go in decreasing order, and then the degree of the polynomial, it's you look for the monomial that has the highest degree, and that's the degree of the polynomial. So let's look. Here's maybe a better way to do this. If we look at this example, 1 plus 3x to the 4th minus 7x plus 5x squared. It is not in standard form because the exponents are not decreasing in value. But if we look here, I take the term positive 3x to the 4th and write it here. And then I don't see anything to the 3rd power, but I see a positive 5x squared, which is here. I see a negative 7x, which goes next, and then a plus 1, which goes next. This is now in standard form, and the degree of this polynomial is 4. I want to see something, and I just noticed my notes are out of order. Okay. As we look here, there's a lot of information here. So let's take it one line at a time. And what we're going to do is look that whenever you have a polynomial, you can name the degree it is and name it using the degree. You can state the number of terms and name it using the number of terms. So for 7x plus 4, it has an exponent of 1 on the x, so it is a degree 1. That means it's linear. We learned about this earlier in the year. It's a linear function if you were to graph it, and it would look like basically a straight line. It has 2 terms, the 7x and the 4. And that means that with those 2 terms, it's a binomial. 3x squared plus 2x plus 1, it is degree 2 because of that exponent there. It is quadratic. That's what we're going to be learning about a little bit in this unit and the next unit. And if you were to graph it, just so you know, it'll look like this, but that will come. It is 3 terms, 3 monomials being added together, which makes it a trinomial. You can look at the rest of the table, maybe pause this and fill it in, and you can come to class in a couple days and ask me some questions on this. What we also want to do is classify polynomials by writing them in standard form. We're going to work on this so we can write each of these polynomials in standard form, state the degree, and name it by degree, meaning is it degree 1 linear? Is it degree 2 quadratic? Degree 3 would be cubic. Degree 4 would be 4th degree polynomial, and 5th degree polynomial would come after that. and you can state the number of terms and name it by the number of terms. Is it one term a monomial, a binomial, a trinomial, and after that becomes polynomial. So please pause the video, fill in the rest of the table, and when you're ready, come back. Now that you have your table filled out, you can check your answers right here. And here are the answers for you guys to look at. I hope there are no mistakes here. And I'll go over, let's look at number 2. I'll go over that and then we can talk more next week. I see a 3x to the 4th here. That's going to be the first term. It's the highest degree. Then I have a 5x cubed is the next highest degree. A 2x squared is here and a minus 4 is next. It's degree 4. That is the highest exponent I see in that first term, 3x to the 4th. It's a 4th degree polynomial. It has 4 terms that each of those are underlined, so you can see 1, 2, 3, and 4. And it is a polynomial. After 3 terms, it just goes to blank, like plain old polynomial. So check the rest of your answers, and because you asked, I have a thinking for you, thinking game. So how many squares are in this picture? And I don't know, but pretend that each one of these little shapes that you see here is a square. So how many are in the picture? And we'll see you next time.